Hello and welcome to another episode of the Construction Corner Podcast. I'm Dylan, I'm your host, and today, guys, we are going to talk about really what it takes to get a project out the door. Now, a lot of this is going to center around equipment, lead times, putting a project together, getting budgets together, and really what this ultimately takes to be basically successful in putting projects out to bid and doing true design build, right? Like we're designing a project, we're getting pricing on equipment, we're getting pricing on cabling, we're getting pricing on everything that goes into these massive, massive projects. For example, this week we had the opportunity to put a proposal together for a 1 million square foot manufacturing assembly line facility with just massive power requirements. They're also putting in like a 200,000 square foot executive office. I mean, these conference rooms look like command centers. It's so wild. They've got like 40-person conference room tables with 2 rows. So you have like a 15 or 20-person table on each side. So you got 15 and 15 with, I think, 2 or 3 seats on each end. And then you have in the middle row, you have another row on each side that then fit another 10 to 15 people. Like these conference rooms are wild to be in. I've been in a few in my career, and it's crazy when you walk into a conference room and you see like bleachers, like a 3 row of bleachers to bring in like the team or some of these big organizations, and they got to bring in whatever, like the engineering department for a manufacturing company, and there's 100 people that gotta sit in there, and you got another like 10 or 15 at the table, and they're going through whatever it happens to be, right? These are like just insane type of conference rooms. So very high-end executive meeting space. They have basically an auditorium in there with auditorium seating, so it fans out for it. I don't know if there are going to be any risers. I didn't see, it's not in 3 dimensions. I just have a like regular floor plan for this facility, but it's a fanned like auditorium seating down to a single presenter. I mean, just wild stuff for this space. And it's going to be built in on a mezzanine that then is going to look down over production. So I think they're going to have a bunch of glass walls so that the executives, as they like walk through, they can see all the production of the facility as they're going through. They got like their secret back stair to get up to this place, then they got a place for like, I think it's 100 people that are sitting out at their desks in a big cube farm, effectively, with offices that rim the perimeter, a couple executive offices. Just a wild facility layout as we're putting this together. And then you have all the equipment, all the large power consumption pieces of equipment that are in this facility. I mean, it's huge, right? 1 million square feet, huge power requirements. And then as we're going through the project, like I got basically our lighting rep and agency doing all the lighting calcs. I spent an hour just outlining the criteria for the entire building. And then it took him, I think we finished it at like 9 o'clock at night. So it was like 14 hours to lay out the entire building with a couple spaces that we like missed through because there's different assembly lines and packing lines and different criteria that just, there's so much. It's 1 million square feet, right? Ton, big building to get through and figure out. So we got him doing all that stuff. I got like our 1-line diagrams and distribution for what's going to go in power wise, counts and circuiting for all the equipment connections and what's going to go in there, counting and figuring out panels and doing circuit breaker configurations for the panels. So how many circuits are going to go in each panel, what breakers need to go in each panel, how big the panels need to be. The entire 1 line for most of the facility was done, and did most of this in 12 hours. Some of it I had done before and spent another like 10 hours figuring out what needs to go into this facility for the lines that they're going to put in. And then on top of that, today we found additional equipment in the facility that we'd missed. And so now we're talking about adding 2 unit subs, which it's crazy to talk about unit subs as a unit of measure. So a unit substation is a transformer, a switchboard, is basically a package deal. So you bring in your medium voltage or whatever you're going to transform down for it, and then put it into whatever your distribution voltage is. So for this, it's 24,000 volts, so 24 kV, down to 480 volts for our distribution. And then these are double-ended unit subs. What that means is there's basically a transformer on each end, and these are 4.3 MVA transformers, 4.3/5 MVA transformers, 5,000 amp main breaker with 5,000 amp distribution board, a 5,000 amp tie breaker, and then another 5,000 amp board, 5,000 amp main, and then another transformer on each end, right? So it's the same, and it's a unit sub or a double-ended unit sub. So main tie main distribution is what we're putting in. And so these are, I don't know, $1 million, $1.2 million, something like that, just for the gear itself. And we're putting in, again, like these are our units of measure now for this size of project. It's incredibly huge. But what really, in talking about all of this and like true design build, is meeting criteria, meeting deadlines, and really trying to figure out what the best lead times are. Like I'm having real-time conversations with equipment manufacturers and vendors of what they can get, when they can get it. Our contractor partner is getting cable lead times for medium voltage cable, which is like also 30 weeks, which is also totally insane that it takes 30 weeks to get cable for it. But then again, when you're ordering 20,000 feet of cable that we have to pull through a concrete trench, and we have to pull all of that to feed some of these new substations and medium voltage gear to do distribution through the facility, yeah, it's going to take a while to make that much copper, put that insulation on it, and then ship it and do it in a reel. And then for the pull that we have to do for this project in particular, it's going to be from a customer-owned substation. So they have their own substation yard with two 30 MVA transformers in it. And we're going to need to pull medium voltage cable 2,000 feet, right? So per phase, we're going to have to do that. And then 2 sets of 350 MCM copper is what we're pulling. I mean, it's a lot of cable that we got to end up pulling, right? 20,000 feet basically of cable that is going to be pulled. And it's one of those where I don't usually go to site to see guys pull cable, but it's one of those instances where I'm basically booking a time slot, or like, hey, let me know so I can schedule when you guys are going to pull this, because I want to see it, because this is wild, right? You're going to go through a huge reel, right? That's probably 12 feet high with 2,000 feet of cable per phase, right? That you're going to pull in a continuous run. Like, this is insane. These big projects, granted, like our fees are commensurate for the size of project this is going to be. But when you start to work on a couple $100 million projects, you know, your opportunities become great on the other side of it. Granted, our costs are huge. We're going to hire a small army of people to get this thing done and designed and detailed out so that construction can proceed. So a lot of work to be done ahead of us, a lot of responsibility that comes with doing these types of projects. But when you're able to work fully integrated as a team, right? I, as the engineer of record, working with lighting to figure out design, they're putting criteria together, they're doing layouts, they're getting counts and quantities and pricing, to the contractor working with gear distribution and getting all the right switch gear, panels, medium voltage gear, breakers, all the gear that we need to execute the project, some other big medium voltage breakers and line items, and making sure that the manufacturer has everything that they need to button everything up. And the supplier on that side, the contractors doing all the other parts, pieces, takeoff, labor, you know, what they think it's going to take to ultimately put this project together. Everybody's working simultaneously on it. And we got our own little small army, you know, special forces unit coming together to put pricing and a proposal together for the client, and an extremely tight turnaround for high level budgeting. But we're getting real numbers, real quotes, real pieces put together for them so that the owner ultimately is able to make a decision or go, no go, or allocate the funds for it, right? They're going to do this one way or another. And so they just basically need to know how much capital they're going to allocate for it and be able to make decisions from there. So it's really cool when we are able to do these types of mega projects for clients and owners. But on the other side of it, like, you can do this same process for any given scale of project. Actually, on Tuesday, I'm going to meet for a maintenance shop for a disposal company, so a trash management company. It's just their maintenance shop. So it's for their like front end loaders, bulldozers, dump trucks, things like that, heavy equipment that they're going to bring into a shop. We're going to go through the kind of the same process, figure out what the owner wants, sit down with them, understand their equipment needs, their layout, what they want to put in the building. I'm going with the electrical contractor. We've kind of got lighting figured out already for what we anticipate their needs to be, but we'll go through any special requirements for them. And then with the electrical contractor, after we figure out the owner requirements, we'll make sure that we meet all their needs, do the design we need to, fill out any other forms we've got to, and be able to put a full set of drawings together that are ready for permit and submit to the city. So this same process works across really any size and scope of a project. Just usually on the smaller end of a project, pricing and dollar values of panels and gear and that kind of thing are pretty much well known by the contractors. It's when you get into these bigger and bigger pieces of equipment, lead times start to be an issue, which then you can again make engineering judgments based on those lead times for a given piece of equipment. So let's say that something is out 80 weeks, right? Like it's an 80-week lead time to get a specific piece of equipment, or the one that you would want, right? So, okay, well, that's not acceptable. We have to build this thing before then. Okay, can we make, instead of, let's just use a generator for an example, right? You want to have an emergency backup for it. Let's say that a 2 or like a 3 megawatt generator is that 80-week lead time. And it's not, by the way. So don't take that one as a like real number. Actually, we can use medium voltage gear. So let's use medium voltage gear. It's 80 weeks out for a lot of the bigger medium voltage stuff. So I'm talking in 25 kV or 24 kV, 24.9 kV can be in that 80-week lead time. I think I just got quoted like 70 for breaker infill on like substation medium voltage gear. So, okay. 80 weeks. Well, we don't like that. Great. Nobody likes that. Not going to fit anybody's timeline. Okay, so what can we do? Well, we can either go buy refurbished gear from somewhere else, right? And it's UL certified. It gets relisted. It's good to go. Okay. How long can we do that? Well, we can have that in 30 weeks. Oh, I like that much better, right? Now you have a trade-off that is real. And then it's just whether or not you're going to accept that, right? Like, hey, this has been refurbished. It's been recertified. It's good to go. Is it brand new manufacturer's warranty? No, but it's been recertified maybe by the manufacturer, maybe by UL or some other testing authority. So you do have some certainty around the equipment being able to run and function. And then you're saving a full year of timeline on buying this other piece of gear. Well, that's a pretty good trade-off, if you ask me, in doing it. And you might even pay half for it, right? So not only are you now saving, maybe you save money, right? Money may or may not be equal here, right? It might be less, it might be more, it might be the same. So the money piece of it is going to be outside of the conversation. But really, if you need to be up and running, and medium voltage gear is a very key piece of your infrastructure, money probably is not the issue at that point, right? Is can you hit the lead times? And if you can shave a year off of it, right, from 80 weeks down to say 36 weeks, like heck, if I'm going to save 44 weeks on a piece of gear, heck man, that's a whole basically year out of my timeline. Okay, what's that worth? And then that hit your goals and timelines for it. So a lot of engineering choices and trade-offs are being made a lot in design build, especially in real time, because manufacturers and suppliers have these choices. And because you're engineer of record, they're not going to have to go through a submittal review process. They're not going to have to go for an exchange process. It's just, we have a conversation. We kind of bring in the owner, contractor, everybody, for some of these bigger decisions around like refurbished gear is definitely a big owner conversation. But for any given other pieces, manufacturer A or B, right? If I believe that they're equal or see some data sheets and say that they're equal, okay, great. We'll go with manufacturer B and still get the same thing in half the lead time. Okay, great. We made that decision. We move on. Owner doesn't really need to know about those decisions. It meets our criteria, it meets our standards. We feel confident in the manufacturer that is selected for it. And so we're able to move ahead on the project with this different piece of gear. So when we talk about lead times and those pieces for equipment, especially because they are so long, and especially when you do get into more specialty gear, medium voltage gear, high voltage gear, the lead times are insane. So we make sure that we try to work the best we can with our contractor partners so that they can have the best opportunity to make good decisions and give them the time that they need to work through their channels and sources for gear and equipment. With that, guys, design build's the way to go. It's becoming more and more prevalent, but don't get into it because that's our market. So you're on your own. But in all seriousness, like that's how a lot of this is going. You're going to make engineering decisions more and more in a design build type fashion because lead times are just insane for equipment. So you got to make those judgments, and design build is ultimately where that happens. So guys, that is this episode of the Construction Corner podcast. Until next time.